The final video of Chapter 8 will be a quick one. It's going to talk about angles of elevation and depression. So angles of elevation and depression are, elevation is when an angle is going up. So if you were standing still and you looked up, the angle at which you tilted your head, that's the angle of elevation. Angle of depression, same idea, but you would be standing up on like a second floor window and you look down. That tilt down is the angle of depression. So let's draw a couple straight lines for a second. From this point, let's draw a straight line out, and then from a point down here, let's draw a straight line this way. The line that's in between those, let's go here, that is the line that you would be looking down, or the line that you would be looking up from. This angle right here is your angle of depression. And this one is your angle of elevation. And now notice, because these two lines, these two black lines of sight, they're called lines of sight because you're looking straight ahead. Those are parallel. So the two angles, angle of elevation and angle of depression, are actually congruent to each other. So you can use one or the other simultaneously. So a bird is sitting on top of a tree branch. So we have our bird here, we'll just put a dot. And the angle of depression to the feet of an observer standing away from the tree is 35 degrees. Let's make that a solid line. Our line of sight makes a 35-degree angle with the angle of depression. And the distance from the bird to the observer is 25 meters. We're looking how tall is the branch. So if that angle is 35, since this is a right angle, that makes this one 65. That makes it, I'm sorry, not 65, 55. And that makes this one 35 as well. So you could use 55 or 35. I'm going to use the 35, and I'm going to use sine of 35 is the opposite side divided by the hypotenuse. And sine of 35, again, you got to use a calculator. It's not going to be an exact value. Is 0.5736 is equal to x over 25. When you multiply both sides by 25, you get that x is 14.3. And it says to the nearest meter, so x is approximately 14 meters. So the tree branch is approximately 14 meters above the ground. A sun is casting a shadow off of a building, and the building is 35 feet tall. The angle of elevation of the sun, if you were to continue, the sun should be way up here, would be 60 feet, or 60 degrees. How long is the shadow? Well, I have the opposite and I have the adjacent side, so I'm going to use tangent. Tangent of 60 equals 35 over x, opposite over adjacent. Tangent of 60, you're going to get a decimal, 1.7321 equals 35 over x. Now remember, I'm not simplifying that decimal in my calculator. I'm leaving it exact, and I'm not going to round until the very end. So 35 equals 1.7321x. And in my calculator, I'm going to take 35 and I'm going to divide by the answer, which is still that. It's still the last one I used. 35 divided by the answer gets me that x is the length of the shadow, 20.2 feet, and it says round to the nearest tenth of a foot, so we could leave it at, oops, it went away, 20.2 feet. So nothing new really in this section 8.5, just different wording. We're calling it an angle of elevation instead of just an angle inside of a triangle. But essentially, if you label it in the right spot, you're just making a triangle. Remember, it always connects with a horizontal line. It always connects with a horizontal line because the angle of depression and elevation are how far you tilt your head looking up or down from looking straight ahead.